Testing, testing, 1, 2, 3, testing, testing. Thank you. Her name is Marimba. She's a bit of a stinker. Good morning, everyone, and welcome to the smooth jazz sounds of KGALBLCTGGFM, your one-stop shop for all your smooth jazz favorites. Or perhaps I should say, good morning, fancy meat computers. How is everybody this morning? I thought I'd mix things up by pretending to be smooth jazz radio. So anyway, let's see, do we have any announcements? Nothing of note? Well, actually there is, okay, couple of things. So, I only got to this mid-lecture because somebody asked about it last time. So, GitHub, I've asked all of you to produce GitHub accounts for the purposes of submitting stuff during this course. This is fine. In order to clone GitHub repositories going forward into the future, you're going to have to set up an authorization token. Click this link, you'll get instructions on how to do that. It is probable that you will receive an email about this from GitHub themselves at some point in the near future, especially if they detect that you have been authorizing access to your GitHub repositories through Git using a regular password. They'll send you an email to remind you, hey, we're moving to authentication tokens at the end of August, so, you know, I think it's the end of August. I know it's past the end date of this course, so technically speaking, you can ignore this. You can ignore this for the entire duration of the course, except, of course, that they are having some quote-unquote brownout periods where they are going to cut off your access if you're not using the authorization tokens temporarily for a few hours these dates and times. Just to kind of kick people in the butt to say, yes, you need to get your authorization token. It's not a difficult process to undertake. There's a link somewhere in this blog post about it. So yeah, the entire point here is the entire point of using of learning GitHub here is that you will use GitHub going forward into the future of your careers. If you have any project courses or anything in this fine degree of yours, you would probably do well to consider using GitHub to manage your commits and like manage it if it's a group project and all of that fun stuff. We are trying to teach you stuff that's actually useful in this class. So yeah, just be mindful of that. Secondly, attention Mac users, greetings from Penguin Land, that is to say Linux land. Lab 2, which is happening today, is about the Unix file structure. Since you're on a Mac, Macs have a very different file structure from Unix/Linux, so you'll need to get the school's VPN and SSH into Pascal, or you need to set up a Linux virtual machine. I sent that out last week as fair warning. Basically, today's lab is going to be impossible to do unless you have some kind of Linux environment that you can play around in. And if you don't have one natively, the easiest thing to do is to just SSH into Pascal. SSHing into Pascal, that is your simpler option and easier option. Setting up a virtual machine, a Linux box or something, that would be a more difficult, but ultimately more useful to your education option. How's this framing here? There. There. Excellent. So yeah, that's everything I have in terms of announcements. I'm doing well. I'm doing pretty well. Looking forward to getting a haircut sometime next week. Should probably book an appointment for getting a haircut sometime next week. So, we were talking about basic constructs in C when last we spoke. That is to say, yesterday. We'd done the introduction section. Just to quickly recap, comments, / or /*. Include is your equivalent of import in Python. You use curly braces instead of indentation. You use semicolons to terminate all statements. The white space in a C program does not matter. These two programs are equivalent. And everything has to occur inside of main. So, I have a question. How do you get the school's VPN? Well, it's not too difficult. You have to McMaster University UTS VPN. UTS is University Technology Services. So, if you loading. Essentially, if there's a Cisco client that you need to use, and you just have to, like, there are instructions on the UTS website, which we're getting there. I don't know why it's taking so long to load, but anyway, VPN stands for Virtual Private Network. If you Google it, you'll find it and install it, and that's how you do that. Setting up a Linux virtual machine is install VirtualBox, and in the box I have to install Ubuntu. So you can use any of a number of different clients to install a virtual machine. VMware provides one. There are a few that are available through the school. If you haven't got it installed right now, the easiest thing to do definitely would be to SSH into Pascal for it. Absolutely. If you have any questions further, please talk to your TA about it, because I gotta move on these lectures. Hi, Professor Moore. Are all of the labs marked? Yes. What is it? It's 40% of your final grade is the lab marks. 4% of your final grade is attributed to each laboratory exercise. Each one is marked. So yes, I hope you guys have done the lab from yesterday. Grinds teeth. So let's talk C. Let's get seeing what we're doing here. Doop. Open up a fresh terminal. Gotta get into documents and master teaching. This is 1XC3 in the summer. Gotta open up my code directory. Gotta make new directory, topic 4. Gotta navigate into it. There we go. Now I can get it a C program. We'll call it example.c. There we go. So, printf. Printing strings should be nothing new, but let's go over it anyway. You will have seen this already from the the hello world example that we covered yesterday in class. Printf is equivalent to Python's print function. The biggest difference is that printf does not automatically append new line to the end of a string. As with the many things in C, what you see is what you get. You are just printing the string as designated. There's nothing being added to it. There's nothing being taken from it. It's just what you say. And of course, the thing is, when you're dealing with standard output does not automatically add new line characters. So hopefully you guys know what a new line character is. So let's just write up a quick program. Include stdio.h int main return exit status 0 printf. Let's just grab this stuff, copy. Oh wow, that's not gonna work at all. Okay. Interesting. I don't know why it would do that. Gonna just have to type it then. From one string printf to the next new line character. Everyone printf viz lisp. Put a new line character there as well. So if we compile this guy, gcc example.c out example, you see we get the example executable. Executing that, from one string to the next, everyone loves Lisp. So you'll notice new lines occur in standard. You're looking at standard output, right? As I stated previously, a terminal is just a view of standard output. The bash program that provides the shell for you to operate in, it uses standard output to put all of these different things that you are entering and, you're putting it in, you're taking it out, all that fun stuff. This program is breaking things up in new lines according to the placement of these new line characters. If I were to provide 2 new line characters in here, you would have a double space. So so new line characters are extremely important. You have to put them in yourself and manually in C, because again, C does very little for you. You are responsible for doing all of these things that that make your program readable, essentially. We are in C land. We are on the sea, where things are not done for you. You are responsible for doing your own stuff. Your code only looks pretty because you put effort into it. Incidentally, tab characters are also very useful. So, there we go. Let's see. Cool. So, string formatting. String formatting should also be nothing new, but here are some important differences. So this whole lecture is sort of phrased, this is what it's like in Python, this is what it's like in C. Fortunately, because you guys have done Python before, you should have a pretty strong basis for picking up a lot of these C concepts. Because Python is a C-based language, a lot of it is going to be just, you know, I always say it's like playing Bloodborne after having played Dark Souls. You spend the first the first 3 hours of the game just learning what they renamed everything, because everything has the same essential function. It's just a matter of you just have to relearn. You have to learn what they renamed everything. So in Python, strings are delimited by either double or single quotes. Hello is exactly equivalent to hello with single quotes. Single quotes, double quotes means the same thing in Python. In C, single and double quotes have very different meanings. Double quotes are string delimiters. Single quotes are character delimiters. So this should be an interesting new addition to your knowledge of programming. In Python, and I know I mentioned this in 1MD3, but this is where it actually comes in. For those of you in 1DO4, maybe you heard about this, maybe you didn't. But Python does a lot of work behind the scenes to make it look like there's no such thing as characters. Essentially what they do is they consider any character that's long, any string that's consists of only one character, pardon me, they consider that a singleton string, and it's dealt with as a singleton string. So, that's fine for Python, but it's not actually true, in one sense. In C, and, it is the position of this professor and the Unix operating system that C is how programming actually works, and everything that's C-derived or C-based is just adding different, bits and bobs onto C. From the perspective of C, it is definitely a mistake to mix up a character with a string, right? A string is a data structure. A character is an elementary data type. So characters are elementary data types in the same way that integers and floats and Booleans are elementary data types. They're not aggregate types. They're just a single thing. So in C, we have what are called characters. So character C is equal to, shall we say, Q. There we go. Right? This is fine. Compile that, everything works. If I were to use double quotes, we get a warning. Initialization makes integer from pointer without cast. So that might be, that'll be a really strange error for someone who doesn't know what pointers are. So we're going to get into pointers. Pointers are generally considered the most advanced thing that you'll cover in C, and kind of, to some extent, the whole point of teaching you C, unintentional pun, the whole point of teaching you C is to teach you pointers. You cannot understand the memory management system of a computer without understanding what a pointer is, what a pointer does, and how to work with them. And C is a language which actually exposes you to the pointer level. Most languages have somewhat wisely decided that when people are left to their own devices with respect to pointer management, the general tendency is to screw things up pretty badly. So Python hides pointers from you. It is possible to access pointers in Python by taking a, basically the idea of aliasing in Python is strongly connected to the idea of pointers. But essentially, a string literal, like this is pointing to an aggregate data structure. Even if it's only got one thing in it, it's still a thing that points at another thing, right? That's why it's saying this is a, you're assigning a pointer to a character, and that's wrong. Again, it's only a warning. In other languages, that would stop you flat. In C, it's like, yeah, I guess I'll consider it. I'll consider this a valid program. But yeah, so it's a long way of saying it. But in order to actually store a string, you have to use what's called a char star, which is a character pointer. So strings are character arrays. You create a string, a named string, using a character pointer. I'm getting off topic here somewhat, but this is all still very important to cover. So the idea is, if you have something like the word hello, right, and you have another one, which is H E L L O. These two things are exactly the same thing, right? They are precisely and exactly the same thing. So anyway, C's got a few quirks and quarks about it with respect to this type of thing. So we'll get into string handling a bit later in the course. For now, it's just important for you to know that there is a difference between strings and characters. Characters are an elementary data type, just like integers, and that it's a mistake to confuse single and double quotes. Here's a list of special characters that you can insert. So new line and tab we talked about. Alert produces a sound or visible alert without changing the current cursor position. Backslash. So you might be asking yourself, okay, so if this slash character indicates a special character, how do I insert the backslash character itself? And the answer is double backslash. And the way that you insert a quote character into a string is you use the slash quote. You use escape quote. These are called escape sequences. So there you go. Reading from standard input. The following program uses scanf, the scanf standard library function, to read keystrokes from the standard input buffer. So let's try this guy out, shall we? So we've got one integer, I1. We've got an integer, I2. Printf, not printf, printf. Enter the first integer. New line, something that looks like a prompt. There we go. Scanf %d ampersand I1. Ampersand means address of. Printf, enter the second integer. Scanf, interpret that as an integer as well. Give it the address of I2. Printf, the sum is I1 plus I2. if I compile that and run the example program, enter our first integer, 9. Second integer, 18. The sum is 27. Ta-da! Math! Math occurs. So let's explain what's going on in here. So the standard library function scanf reads characters from the standard input buffer stdin. So whenever you're typing on your keyboard and those characters are being entered into the terminal, that is what you're doing is you're populating values to standard input. Some functions, like scanf, will read the stuff that's in the standard input buffer and acquire those characters for, whatever purpose you're turning them to. In this particular case, %d indicates integer conversion. So in C, you have what are called formatting strings. A formatting string tells scanf what data type you want to convert the read input to. This is different from the way that things work in Python. In Python, everything is assumed to be a string. Everything is read in as a string, and if you want to convert it to an integer, you have to perform explicit integer conversion. So in the case of C, you're doing the type conversion and the reading in of the, the read operation, and you're selecting a place to put it all in one line. The only thing that one of the main differences between Python's input function and scanf is that scanf doesn't actually print anything to the screen. You have to manually send something to std out using printf in order to, prompt for whatever you want to input it. So there you go. The first argument is the format control string, which indicates the data type that should be input by the user. $d means integer. F means float. I think B means bool. So let's run this again. Enter the first integer. No. Now that's an interesting result, isn't it? So we have entered something that isn't an integer, and as a result, we've gotten a number that doesn't make sense. So this is, again, one of those things about C. C is really riding the bike without the training wheels. No is being interpreted as it's being interpreted as a number. So this is an interesting thing. And this kind of gets into the idea of data types, which I guess we're going to talk about in a little bit. So maybe I'll leave talking about data types until we're actually talking about data types. But the essential gist of it is variables in C, the only thing that the data type tells C is how much memory to allocate. Everything else is up to interpretation. So, we'll get there. The second argument is the variable we want scanf to put the data in, prepended with the address of operator. That's a spelling mistake. Oops. So this ampersand gives you the address of a variable. So if you think of a variable as being a cell in memory, right? A cell or multiple cells in memory, using the address of operator produces the memory address that your internal operating system uses to look up that variable. It is that variable's location in memory represented as a number. Right? So, when you give scanf a variable to put its data into, You give it, what you actually give it is you give it a location in memory into which to place the result of the reading of the input. Right? So this is all very complicated stuff. Are you guys following so far? Give me some indication of life out there in the chat, please. Ooh, I see our viewership is already pretty down relative to summer courses. Give me a thumbs up if you're doing okay. Yes. We will be covering the ampersand operator in depth when we talk about pointers. Pointers we're going to cover, you know, around the second middle of the course. Like, it's like just after the middle of the course we'll probably get to pointers. Okay, if Alex is following, then okay. Excellent, thank you. Because, you know, this is a very different way of thinking about programming than you would be used to in Python, right? This is like... I hesitate to say this is real programming, but... okay. So, like... in order... If you know Python, you can write a program for Python, right? If you know C, you can write a compiler that implements Python, right? So this is, like, the stuff that you can do with C is way beyond anything that you can do, like, because you're working your toes into the sand of the operating system itself. But anyway, I'm having trouble with the new line command. It doesn't seem to work. Sometimes. It'd be difficult to tell what's going on there without seeing your code. It'd be difficult to see without seeing your code. But, so either talk to your TA during lab today, or find me at office hours, or even if you put your line, the line of code that you think is giving you trouble into the chat, I'll probably be able to diagnose it that way. So, to print the value of a variable, you must first use a format specifying placeholder in the first argument of printf, and then supply the variable as the second argument. Each data type has its own placeholder. So, you may not have known this, but printf can actually take a large number of arguments. I1, I2, there we go. The number of arguments that you provide after the first should be equal to the number of placeholders that you leave in the number of placeholders that you leave in this string. So, for example, if I do d plus d equals d, new line, provide I1, I2, and this guy. Oh, there we go. 1 plus 2, the sum is 3. There we go. You know, oop. So, you know, you can do all kinds of interesting and fun stuff here. Add, subtract, multiply, and divide. 2 and 2. Oh. Gotta recompile that. There we go. So, 2 plus 2 is equal to 4. Very true. 2 minus 2 is 0. 2 times 2 is 4. And 2 divided by 2 is 1. So, the number of placeholders here is equal to the number of arguments provided. Right? If you want to, like, there are ways of converting between data types, but this is, generally speaking, not the way that you would do it. If you want to do inter-type arithmetic, say between integers and floats, better to do that outside of these printf and scanf statements. And always, so essentially the rule of thumb is that these should always match the data type of whatever you're working with, right? Don't be too fancy, essentially. Good. Every data type has its own placeholder. At some point, we'll go over a whole list of these. Oh, yeah. That would be it. That would do it. Yep. So, one of the absolute essential things about programming in a Linux environment and using C is learning the difference between forward slash and backslash. Incidentally, it took me so long to figure this out, but the reason that this is forward slash and the reason that this is backslash is leaning backwards relative to the progression of text, and forward slash is leaning forwards relative to the direction of text. I don't know why it took me, 33 years of my life to learn the different why backslash is backslash and forward slash is forward slash, but there you have it. You learn something new every day. So in Unix, forward slash, generally speaking, those are your comments, and those are directories in your directory structure. Like, you can see it all over the place. And backslash is almost always just for the escape, for doing escape characters. In fact, so if you take a look at, like, URLs, right? Ever wonder why of backslash? That's because all of these servers are running on Linux, folks. All of these things are Linux-based or Unix-based. Ba-da! Incidentally, HTTP stands for Hypertext Transfer Protocol. So let's talk about variables. You may have noticed that the above program uses variables. Variables in C work the same as in other C-based languages. Roughly speaking, so the manner in which a C variable operates is precisely equivalent to how a Python variable operates. Assigning to it overwrites the value. You can read it as many times as you like, but you should write to it only once. Why isn't it like that for Windows slashes? Ho-ho! Isn't that a question? Probably because Windows is terrible. So, Windows is not a Unix-based operating system. Windows is kind of its own little thing. It's often its own land. Like, Windows was developed independently of Unix and all the rest of it. So, Unix derives from Bell Laboratories at AT&T, right? AT&T's Bell Laboratories. Windows derives from Bill Gates programming an operating system kernel himself in his basement and then licensing it to IBM. All right? So the only reason that Windows is popular at all is because Bill Gates is much better at business than he is at programming. Because he managed to convince IBM being a primary, like, one of the primary manufacturers of computer systems in the, 70s and 80s. International Business Machines is what IBM stands for. And if you increment each letter by one, you get HAL, which is HAL, which is the evil robot from 2001: A Space Odyssey. Incidentally, or the evil computer from 2001: A Space Odyssey. So, IBM wasn't really completely sold on the whole operating system thing for a long time, because IBM, as a company, it has, like, this extremely conservative culture. It's kind kind of interesting for a computer company to have such an extremely conservative culture. But then again, IBM computers really work well, and they're very consistent in their operation. So when you're doing like military or government operations that require really good hardware, IBM is a good person to go to. But anyway, so Bill Gates, and I think I'm getting this story correct. It's somewhat apocryphal. IBM didn't realize that operating systems would be like the primary like IBM was primarily making computers for programmers, right? Bill Gates saw that the application of operating systems was going to be the future of computing. At the same time, this was realized by a few other people who made a few other different operating systems. Primarily, I think Windows came after Unix. Certainly, Windows has Unix-like characteristics, but to some extent, some of the design of Windows was primarily to be contrarian. This is not Unix, sort of thing. So anyway, he managed to get a meeting with the IBM guys and sell them his operating system, and he got a contract that all of the he got a contract that a certain amount of the money for each IBM computer that was sold had to go to him because he wrote the operating system. And so, as he correctly predicted that operating systems would become essential to the use of computers by normal people, right? The normal people market is usually one that you want to go after if you're marketing a product. So operating systems became indispensable. He had this fat contract with IBM. IBM, Windows was, and that's essentially where Windows came from. The original selling point of Windows was the window. So this thing here, that was the original selling point. It was like the introduction of a certain degree of graphical user interface, although I think some people sort of Windows came actually after this is completely off topic, but this type of visual interface was actually originally developed by Macintosh, right? The Apple guys originally came up with like a visual GUI interface. And that's primarily because they were the ones who invented, or they were one of the first adopters or popularizers of mice. Oh my goodness. Yes. So mice are like largely, the popularity of mice is largely attributable to Apple. Bill Gates was originally working on this thing called MS-DOS, which you can still access in Microsoft DOS prompt. DOS stands for Disk Operating System. So DOS was the thing that Bill Gates came up with. It eventually became Windows when he stole Steve Jobs and who's the other guy? Wozniak's. When he stole Jobs and Wozniak's good ideas and integrated them into DOS, you get Windows. And he had a few minor innovations of his own. The primary one being that everything pertaining to the operation of the program should be contained within the window. Whereas, to this day, Macs and even this GNOME environment uses the taskbar at the top as an extension of the options of the program that's currently open. The difference with Windows is that all of the functionality is contained within the window that is the program. So that allows the user to think of the window as being the program to a greater degree. So, it's to that extent, yeah. But anyway, so that's Windows. And, they've been fighting it out ever since. Unix users don't like Bill Gates that much. Yeah, no, he's evil. Oh my gosh. Yeah. Oh, did they? Did they? Okay. Yeah, probably because I knocked it over. So, yeah. So, let me wait. Yeah. So let me explain. Yeah, let me try to explain to you the origin of the deep animosity that's felt between the Linux crowd and the Windows crowd. So, because of his favorable business dealings, by the late 90s, Windows was the overwhelmingly dominant operating system. And you guys won't remember this because you're too young, but I remember this. I remember the lawsuits. Essentially, what happened was the US government had to come in and try to break up Windows because it was monopolistic, right? And it was engaging in monopolistic business practices. And the Linux crowd have always been a bit more... they've always, like, it kind of comes down a little bit to the attitude of the programmer versus the attitude of the businessman. You know, there's always been a bit of a contention, a little bit of a rivalry between those two factions, because, you know, programmers fundamentally sort of, you know, don't want to be bothered with human beings, if that makes sense. And business people think that human beings are the best, especially when they're buying things. So, essentially, Microsoft was getting way too big for its britches. The U.S. government had to come in with antitrust lawsuits against Microsoft, try to break it up into its different divisions. I believe as a result of that, Bill Gates had to step down as the CEO of Microsoft. I'm pretty sure he's not the CEO anymore. Something like that. And, you know, Microsoft got broken up, and to some extent, although you wouldn't be able to tell that now. But, you know, all of the Linux crowd, the Unix crowd, were like, licensing is terrible. It is just a mechanism for corporate fat cats to make money. We will start our own movement of free software, and that's going to take over the world because you can't beat free. And they're right. So this, you know, Linus Torvalds, our good friend Linus, he said, I will have won when Microsoft starts writing applications for Linux. And guess what we had a few years ago? The Linux subsystem for Windows. So, guess who won? Linus Torvalds. That's right. So anyway, let me get back to this. So, variables. So, in contrast to Python, C variables require explicit declaration. In Python, the first assignment of a variable is considered its instantiation, and you don't have to worry about instantiating it with a declared data type. In C, every variable must be declared with a data type. In this case, in the previous case here, we're using integers, but you can also use floats or bools or you know, characters or whatever you want. So, declaration, this is called declaration. This is called instantiation. When you declare a variable with an initial value, this is known as instantiation. So, we could, and often want to, include, you know, something like this to set the initial value. So, so why do we have to declare data types? In C, a variable is a block of memory. The size of that block of memory is told to the compiler by the declared data type. Ints have a certain size, floats have a certain size, chars have a certain size, Booleans have a certain size. And because it's at this level, like, because there's so little that's being done for you by C, if it doesn't know how big the variable is supposed to be, then it can't declare it, right? In Python, you don't have this problem because Python has all of these subroutines running in the background to ensure that your variables are not exceeding the size declared for them and stuff like that. In C, you declare a size for a variable. If you exceed that size, i.e., if you try to add one more to the maximum integer size, you get interesting things like wraparound. So let's see here. I can show you some of this. So here are your standard data types in C. You've got short and unsigned integers. Unsigned integers are just integers only capable of storing positive numbers. You've got long integers. You've got long integers, which are also still 8 bytes. This is according to the most recent C standard, by the way. So short ints take 2 bytes. Regular integers are 4 bytes. Long integers are 8 bytes. So those of you who are in the know will know that right now we're operating in the 64-bit processor paradigm, right? What that means is that the CPUs that we're currently using can process 64 bits in one operation, right? So 64 bits is, of course, 8 bytes, right? 64 bits, 8 bytes, 2 to the 8 is 64. So we've got 8 bytes, 8 bytes for a long integer. So actually, the standard integer that is used in C these days is half the size of the current word size of the operating systems we're all using. Signed and unsigned chars are all 1 byte, so only 8 bits. Floats are 4 bytes. Doubles are 8 bytes, and long doubles are 16 bytes. And you can see we have different placeholder tags for each of these different data types. So let me show you something cool. Let me just do couple of things. Number one, if you declare and let's work with a short unsigned integer, just because that makes it easier. We will leave it uninitialized. What do you think happens if we print it? Oh my God, come on. Work with me here. There. HU. What do you think happens if we print it? Oh, with printf, of course. There we go. Let me just put a new line in there so that we can see it. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So before something has been initialized, it doesn't it won't clear the memory, right? Now this memory, I actually reset my computer not too long before the stream, so it's probable that my memory just doesn't. My memory is still primarily blank from my system reboot, but when you declare a new variable without initializing it, it's filled with garbage data. It's filled with old data. When a program is not using memory anymore, it does not clear that memory. It just destroys all references to it, so that memory becomes, it just floats around inside of your RAM. It's not pertaining to anything. It's just random data floating around. And if you happen to instantiate a variable, or if you happen to declare a variable, you take a chunk of memory. If there's already bits that have been flipped in there, if there's already some data that's in there that's lost all context, that will be the initial value of your variable. The same thing works with arrays. Most of the time it'll be 0, but that can't be relied upon. In order to clear that data, you have to initialize to 0, or initialize to whatever you want the initial value to be. I is junk data until it's been written to. That's an important thing to know, because that's very different from how you think about things in Python. So, let's fill this data up with the maximum value that it is possible to write inside of a short unsigned integer. So the maximum integer, and this is hexadecimal, by the way. Don't worry about that right now. Basically what this is I'm setting every bit in this integer to 1. So the maximum value that can be stored in a short unsigned integer is 65,535. What happens if we add 1 to it? I++. And then print it again. What do you think is going to happen? It goes from 65,535 to 0. Adding 1 to the maximum number that can be stored in a variable wraps that number around back to 0. This is actually how computers work. This is how the CPU works. Right? The CPU does things like wrap around integers. Various programming languages that you've used, like Python, they go to an awful lot of work to ensure that you're not wrapping around your integers. In fact, when an operation like this does result in wraparound, there's a flag that's raised inside of the CPU to indicate that a wraparound has occurred. What Python is doing is it's watching for that. Flag when that flag gets raised. Rather than allowing the wraparound to occur, it rolls it back to the previous operation, allocates more memory to that integer, and then it allows the calculation to proceed with the expanded memory. Now this is a very that's a very useful thing to do if you're not good at guessing how much memory you're going to need for the variables that you're using. But all of that stuff that's happening in the background, that's all costing you CPU cycles. And it's costing you CPU cycles like every time. Because every time you perform an addition operation, Python has to check for overflow. It slows you down. In C, you're not checking for overflow unless you do it manually. And as a result, you can just go, you don't have to spend all of those extra CPU cycles. So, yeah, one more thing about that, and then I should really keep going on this lecture. I can do it. This is important information. Civilization, right? The Sid Meier's Civilization games. I probably have talked about this in 1MD3. For the benefit of people who haven't heard this story, Civilization is a game where you have a planet and resources on the planet, and you build cities and raise armies and try to be the best civilization and make it to the moon first, or make it to Mars first. The AI of the other nations in Civilization, these are computer constructs, of course. One of these leaders is Gandhi, right? Gandhi of India is one of the leaders, and his, being one of the world's most famous pacifists, Gandhi's Gandhi's algorithm that dictates his behavior sets him as like one of the least aggressive, or the least aggressive civilization of all of them, right? Gandhi will probably never declare war on you. So, in one of the civilization games, one thing that people were noticing is that Gandhi had this tendency to wait until the development of nuclear weapons, then stockpile nuclear weapons, and then just obliterate the entire globe in nuclear holocaust. And the reason for that is there are modifiers on the AI's personality score based on their relationship with you. So if you have a good relationship with Gandhi, that reduces his aggressiveness even further. So what was happening with Gandhi is that his aggressiveness was being lowered past 0, which meant that his aggressiveness was wrapping around to the maximum level of aggressiveness possible, which in the course of a civilization game meant nuclear annihilation. And I think in subsequent, this bug became so, so interesting for its emergent gameplay, shall we say, that in subsequent versions of the Civilization games, they left that in, that behavior in Gandhi. So, if you're ever in a Civilization game with Gandhi, the best thing you can do is piss him off. Anyway, so this is the level at which you're having to deal with things in C. Fuzzies on my camera. Anyway. So don't give me that bool. You may have noticed that the foregoing slide did not have any Booleans on it. Boolean support was actually only added to C in 1999. Unlike most other languages, Booleans are not a part of the C prelude. So Gandhi. Well, it's not that they intentionally made Gandhi a nuclear warmonger. I think it's like you have, if you do the same conditions out with him, then that's the result. I don't know. I haven't actually experienced this. I've never had Gandhi go nuclear on me when I've been playing a Civilization game, and holy smoke, I have put enough hours into Civ 4 in particular, which is the best one. Civ 6 just takes too long to read. But anyway. So most other languages, like Python, a prelude is the stuff that's loaded by default without you having to ask for it. C doesn't have much of a prelude, but you do get stuff like function definitions and if statements and all of the regular language constructs. Basically everything else has to be loaded in manually. Python, you don't have to load stuff in manually. A lot of the time, it just gives it to you automatically. So, basically, in order to use Booleans, you have to include standardbool.h. Add this line to your include statements if you want to use Booleans. After that, you can use Booleans in the way that you're accustomed to. Before this library, C programmers would use integers to represent Boolean values. So, in actual fact, this is how Booleans are used under the hood, right? Boolean, as a data type, is really just masking this manner of operation. 0 is false. Any other value is true. 1 is typical. So that's how, if you were to take a Boolean and integer convert it, that's what it would look like. So, here's some more memory concepts. Variables are units of memory that have been assigned an identifier. The amount of memory allocated is dependent on the data type the variable is declared with. See this table. C will only allocate as much memory as you're asking for. The specific arrangements of 1s and 0s at the memory's location indicates the value of that variable. So, the value of a variable is the actual the actual ones and zeros in that memory cell, right? In higher level languages like Python, we're used to thinking about values as being, oh, it's, a string, the string value, the string literal. When you're talking about C, you need to understand that everything is in binary, right? Strings are stored in binary. Bools are stored in binary. Floats are stored in binary. Everything is binary because it's a binary computer, right? C brings you to that level with it. When a new value is assigned to a variable, the underlying memory is overwritten with the new value. The process is destructive. Reading variables is non-destructive. You do not destroy a variable when you read it. When you write to it, the ones and zeros are overwritten. The old values are lost and the new values are retained. Is there something like include star to include everything like in Java? It's easier. Not to my knowledge. Not to my knowledge. So C is not an easy language, but it's a fair language. So the purpose, again, of learning C is so that you learn how your computer actually works. Java, the more a language does stuff for you, the more you don't know what it's doing for you, right? So yeah, no, there's no easier way to do it. It just is what it is. So, static versus dynamic typing. In Python, variables do not need to be declared with a data type. This is dynamic typing. In fact, the data type of variables can change through the execution of the program. The Python interpreter manages the memory representation of the variables. You have the Python interpreter as your nanny, following behind, cleaning up your whoopsies. In C, the type declaration tells the memory system how much memory to reserve for the variable, so the information must be present. Must be present. You have a certain degree of equivalency between data types that have the same memory width, or bit width. You'll hear me use the term bit width. That just means the number of bits that the variable uses. Bit width. So you have to know how much memory you're reserving in C. That's the purpose of the static declaration, is so that C knows how much memory to manipulate. If it doesn't know how much memory to manipulate, then nobody else is going to tell it, so it just doesn't work. And you get, if you mess this kind of stuff up, you can get some very weird classes of errors, like the top halves of integers being lost, which is essentially what's happening with wraparound. Anyway, so this is known as static typing. So when you declare a variable in C, that variable has a declared data type. That data type does not change throughout the entire execution of the program. If you want something with a different data type, declare a different variable. Variables in the same program will not necessarily be allocated to adjacent memory cells. That's not true for, that is true for pretty much any programming language. But yeah. If you want variables to be declared in adjacent memory locations, use an array. That's what an array is, and we're going to get to what arrays are in a couple of lectures. So, operator, get me Chicago. Here are some operators. Incidentally, I dropped the bitwise operators from this list to make this lecture shorter. I also dropped the stuff on goto statements, so if you're interested, look up bitwise and gotos. I don't think, it's kind of tricky because with this course, normally I would have more time to be able to get into those types of details with C, but because we're covering so much Unix stuff in this class as well, I have to be a little more conservative with the content, unfortunately. But If you have any questions about that kind of stuff, I'd be happy to answer it during office hours. So, here are your operators. First set of operatings. Increment and decrement. Prefix and postfix. Prefix, postfix. These mean different things. Negation, negative x. Arithmetic addition, subtraction, multiplication, division, and modulus. These are things you should know pretty well already. Here is something, but you will not have seen increment and decrement unless you've worked in a language other than Python. Python drops these because Python's approach to things is, if it's redundant, why does it exist? Which is a stupid thing to say. But anyway, because increment and decrement correspond to operation, like CPU operations, that's the reason they're in C, is because there are specific commands in your processor for these operations. But anyway, increment and decrement operators, plus plus and minus minus, respectively, either add or subtract 1 from the operand. Plus plus and minus minus use implicit assignment, so no assignment operator is required. Whether the operator is postfix or prefix affects the semantics. If it's prefix, the increment is executed before the containing expression, and if it's postfix, the increment is executed after the containing expression. Because this implicit assignment using increment and decrement on integer literals is a syntax error. Sorry, let me say that again. If you do these operations on integer literals, that's a syntax error, because literals are not variables. These have to be variables they're applied to. So, 5 plus plus does not get you 6. So you can see I'm using plus plus right there. But yeah, we have a somewhat more interesting example. Yeah, no, for a big project, it's often going to be the case that you'll have, 5, 6, 7, 8 include statements at the top of your file. C is not a very compact language. C files get pretty large pretty quickly, so just keep that in mind. So here we go. We have variable 1 and variable 2 both set to 5. We display variable 1 using postfix increment. We display variable 2 using prefix increment. I'm not going to do it out in terminal, but the result is that variable 1 will equal 5, and variable 2 will equal 6. And if we were to test for equality between variable 1 and variable 2, after these two print statements, they would both be the same, and they would both be equal to 6. There you go. Here are some relational operators, also known as comparators. You've got equality, inequality, greater than, equal to, less than, equal to. This should be pretty much the same as stuff that you've seen in Python, with the exception of this one. Bang means not, so not equals. The way that you would probably do that in Python is not x equals y, right? But, this is not Python. In C, in Python, they just use these words as the operators, but in C, we actually have symbols for that. Because generally speaking, we don't use words when you're programming unless they're if and while and data types. So, not is just the Boolean inverse, and you express it by prefixing the exclamation mark. And is 2 ampersands, and or is 2 pipe characters. So if you don't know where pipe is on your keyboard, it should be right above your enter key. Everybody take a moment to look for your enter key. For your next assignment, so assignment operations, we've got all of these combined assignment and arithmetic operators. So we've got assignment plus addition, subtraction, multiplication, division, and modulus, which should be fairly good. So I'm going to take a moment to ask if there are any questions. Are there any questions? Because if not, we will move on to elementary control flow. Give me a thumbs up if you're doing okay so far. How's viewership? Oh, man. Did you guys lose the signal there for a second? Looks like we might have lost the signal. Oh, heck. I just realized I'm streaming this on Wi-Fi. I don't even have my Ethernet cable plugged in. Where even is my Ethernet cable? What? Did it fall back down into the basement? No, almost. Oh my goodness. Okay, I'm gonna... You're probably gonna lose the signal for like a minute or two. I'm gonna, well, I mean, if we've come this far, it'll probably be fine. Sorry about that, guys. Cool. All right. Sounds good. So let's talk about control flow then. If statements are a bit different in C versus Python. So in C, you've got if, condition in parentheses. In Python, the parentheses are optional, but in C, they are not. You then have curly braces, else statement, curly braces, and you put your statements in the middle. Again, the indentation level does not matter. One thing in particular, where Python uses elif, C uses else if. Else if. So it's, you know, it's just spelt out. Otherwise, the semantics are the same. Here is a comic. Mom, can we get an if statement? No, we have an if statement at home. The if statement at home. While condition, statement 1, break. While not condition, statement 2, break. That's a programmer. If you can look at this without having your like spine rip itself out of your body in embarrassment, then you're not a programmer. So let's switch just in case. I actually heard that Python is adding switch cases to itself. Like the Python people have decided that they've put up with the charade long enough, and they're actually adding switch cases. Yeah, yeah. He says, "Lol, rip your Wi-Fi." Maybe. I think. Sometimes, like, I'm not sure the degree to which, like, the upload packets are separated from the download packets. I don't think I'm doing a whole lot of download at the moment, but, you know, let's just say if things start, you know, let me know if it starts getting a little choppy and I'll plug the Ethernet cable in, but I'm not sure it's worth the, like, 2 or 3 minutes it would take the connection to reset at this point in the lecture. I'll try to remember it, though. I'll plug that in as soon as the lecture is finished, so that next week. Because that's how much my laptop moves now that we're all stuck at home forever. Anyway. So, in Python land, they said, why do we need switch statements? All we need is branching else-if statements. So, this is what a switch case looks like. You switch on some expression, and each case executes if x is equal to the number that it's indicating. right? So basically, it'll jump to whichever case matches the x that's, or the expression that's specified, the like calculated value of the expression. This is basically the same. This is a kind of a controlled goto construct. It kind of jumps to any particular one of these tags. Like, if you know what a goto looks like, these are goto tags with an argument. But anyway, so to get out, so if you only want the code inside of this case to execute, you have to put a break statement in there at the end of it. So you only exit a switch case when you hit a break statement. So in this case, if you look at case 2, there's no break statement here. That means that control will flow into the next case. So if we get here, and x is 2, execution will jump to case 2. It'll do everything in there. Then it will continue on to case 3, and it'll do everything in case 3. So the stuff in case 3 is essentially executed if x is 2 or 3, right? And then it takes a break statement. And of course, you have a default tag, which executes if none of the other cases were true, right? It's like your else case. So, switch statements. Why would you use a switch statement as opposed to a branching else ifs? Because you don't have to write as much, right? The equality comparison is implicit in this construction. So you don't have to do as much typing if you're using switch cases. And there are definitely situations in which it's appropriate to use a switch case. Personally, I actually do use switch cases and when I'm doing programming, and in a programming language that supports such archaic constructs. Whenever you have, a set of options that must be executed based on the, like if you have a program that moves through various states, like you have a state variable. If state is 1, do this. If state is 2, do that. If state is 3, do this other. Any construction like that, a switch case is a good option. So, in this example, x is the controlling expression. The value of the controlling expression is compared to each case label, which is a literal of the return type of the controlling expression. So if this guy will evaluate to a float, then these should be floats. If this evaluates to a bool, then these would be bools. I don't know why on earth you would use a switch case for a Boolean, because it's only got 2 cases, and you can very easily, like, if it's Booleans, just use an if statement, an if-else. Like, gosh. Like, yeah, it's primarily for integers and enumerated types. Execution jumps to the corresponding case and exits the switch block when it hits a break statement. This means that execution may pass through multiple cases before exiting the switch block. Default functions, the default tag functions like the terminating else of an if-else chain. If no case matches the value of the controlling expression, execution jumps to the default clause. There you go. This is a swift visualization of what a switch case looks like. In theory, proper form is to put a break statement inside of every case, but as with a lot of different things in C, if you can think of a situation where that break statement shouldn't be there, you have the option to get rid of it, and C will not complain. So here's an example. Let's switch to an example. Char grade, enter your grade. The grade is entered. Switch on grade, case A, printf, amazing, a smart person. Case B, you have met expectations. Break. Note, if you got an A, it also tells you that you met expectations, which is true. Case C, you need to study harder. case D, at least you passed. Notice if you get a C, it also tells you that it also consoles you saying at least you passed. And F, print, well, they're always hiring in the Army. Break. Default, that's not even a proper grade. So there you go. Demonstration. No, I think I left that file in 2mp3s folder. Whoa. 2mp3. Last fall, I taught a C programming class. It was just C programming. A lot of the it's a second-year class for mechatronics students. I'm not going to say so it's a first-year class for everybody else. That's just mean and not true. The mechatronics people are actually quite smart. They have mechatronics has one of the higher entrance averages for engineering programs, actually. Ah, there it is. Sarcastic grades. So cat sarcastic grades .c. There you go. There's your program. And if we execute sarcastic grades, enter your grade. A. Amazing, a smart person. You have met expectations. D. At least you passed. C. There we go. And F. Well, at least they're hiring. They're always hiring in the Army. There you go. So that's how a switch case works. Ta-da! Cool. And talking about loops. Loops, of course, being a bit more difficult than if statements. I hope that if you took 1MD3 or 1DO4 and you weren't good at loops, that you didn't decide to major in computer science, because loops are kind of essential. You're not gonna get very far not knowing how loops work. But anyway, so in C, you have 3 styles of loop, and they're all basically styles of the same type of loop. In Python, there are some very distinct differences between for loops and while loops. In C, you must abandon the idea that for loops exist in the Python sense. There's no equivalent structure in C to the Python for loop. Everything is various flavors of while loops, including the C for loop. In addition, there are 2 control statements for use in loops: break statement and continue statement. So let's see how this works. Do while I think of another pun. While loops in C work the same way as in Python. Do while loops are a slight variation. So, again, you guys remember while loops, I hope? So with a do while loop, you have some initializing statements. You say do, you have some statements, and then you have the while condition at the end. While condition, there you go. Terminated with a semicolon. While loops test their conditions before each loop iteration. A do while loop tests the condition after each loop iteration. So if you're writing a loop and you're like, man, I really just want it to run this loop the first time regardless of what's inside of it. If you always will need to execute a loop at least once, you should be using a do while loop. There you go. This means that a do while loop must execute at least one loop iteration. Aside from that, there is no semantic difference between while and do while. It's just, all it is modifying when you're testing the condition, at the beginning or at the end. And since it's a loop, the beginning and the end are basically the same thing once you've gotten through the first execution. Formidable coding. In Python, a for loop is used to iterate over the elements of a data structure, lists, dictionaries, etc. In C, the for loop is just syntactic sugar for a while loop. It's not even that sugary. So here's a while loop. int I is 10 while I is greater than or equal to 0. Print the number, and then decrement I, right? So basically this is a countdown from 10. The same thing using a for loop. For int I equals 10, I is greater than or equal to 0, I minus minus, print the same thing. So basically, all you're doing is you're taking this line, and the condition, and you're sandwiching them all inside of the brackets and putting semicolons in there. And that's what a for loop is. Semantically speaking, once you've done all of that, it operates in exactly the same way as a while loop. Now, the reason that for loops are used, and preferable in some cases to while loops, is because of the manner in which it's been constructed, because it has this, initialization, condition, and change construction, it's less likely for you to forget to include this line, for example, inside of a for loop, and therefore it's less likely for you to get into an infinite loop, although still very possible. In fact, it's like, this is like the typical C attitude towards its programmers. It's like, oh, so you want to get in fewer, into fewer infinite loops, do you? Okay, I'll give you a language construction that will remind you not to get in them quite as much, you silly, silly person. It's like, you are the person. This is the computer. So, let's talk about continue and break statements. Two statements may be used to control loop execution outside of the loop's main conditional. Break exits the loop, and continue starts the next iteration. So, when you're executing a loop, going along, if it hits a break statement, that loop, whatever loop you're in, immediately terminated, as if it came out with a false condition test. Continue, if you're iterating along, and it hits continue, it jumps immediately back to the beginning of the loop. It just jumps to the beginning of the loop again. So, break. When the program pointer hits a break statement, the loop it's in is immediately terminated, as if its conditional test had returned false. Break can be very useful for programs with complex logic. The truth literal can even be used as a loop condition if the program breaks the loop correctly. Break is also used in switch case blocks. So, generally speaking, it's a bad idea to write an infinite loop, but sometimes you write an infinite loop, and then you put something in that breaks that loop, based on some complex series of conditions. Something more complex than you would put just in the, just in the condition statement of a while loop. Continue starts the next iteration. It jumps immediately to the next iteration of a loop. The applications are not as numerous. Most people use if branching to not execute the rest of a code inside of a loop. But continue can reduce the indentation level of your code. So rather than, not executing these statements and using continue to jump back to the top, people most of the time will just gate that off with an if statement, and that's perfectly legitimate. In fact, in general, you should probably reduce the use of break and continue wherever possible in favor of if statements and loops, just because all this jumping around can make your program more and more like spaghetti code. But, yeah, anyway, so that's the end of this lecture slide. We have a little bit of time left, so I think I'm going to cover some of the stuff I dropped from this lecture. I'm going to show you some of the dark arts. I'm going to show you evil practices. No. That's the wrong framing. We're going to have a little bit of defense against the dark arts in our class today, as soon as I do this comic with you. So, how to write good code. Start project. Do things right or do them fast? Fast. Code fast. Does it work yet? No. Almost, but it's become a mass of kludges and spaghetti code. Throw it out and I'll start it all over. Do things right or fast? Right. Code well. Are you done yet? No. No, no, no. No, and the requirements have changed. Throw it out and start over. Good code is coming from where? We don't know. That's an XKCD cartoon. All right, so let's talk about goto statements. Just for fun. We have a little bit of time, so let's talk gotos. Where it is here. There we go. Cat. Not cat. What am I doing? Ocular. Events. Better for presentations. There we go. All right. Bloop. So. All right. So, there we go. So, just a quick note on goto statements. You should never, ever, 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 ever use them. Don't ever use a goto statement. The only reason I'm covering goto statements in the context of this course, the course that these slides are from, 2MP3, is because that course also covers assembly programming. And in assembly programming, you don't have any control flow other than goto statements. So it's good to introduce goto statements. And they do, like, goto is valid C. Like, it will compile, it will execute. But they're a bad idea, and we'll go through why. A historical note on goto statements. At one point, there was no such thing as an if statement. If statements were an innovation. Program execution was controlled by goto statements. A goto statement changes the value of the program pointer to some other spot in the code. So the program pointer, essentially, inside of your CPU, there is a register that is maintained to tell you what line you're on in the program you're executing, right? When you execute a line of code that's a regular statement, like an assignment statement or something, that program pointer is automatically incremented by 1 so that it points to the next statement, right? And the next statement, and the next statement, and the next statement. What if statements and while loops and functions and all of these things do is they are manipulations of the program pointer. When you call a function, the program pointer is moved to that function definition, and then it executes that function, and then it's popped back to where it was, right? In general. So, you know, this is what it means to have a stored program computer. So, it used to be that people primarily manipulated the program pointer directly using goto statements. So you would leave labels in your code, and then you would go to a label in C code, and then that would bring your program execution to that label and then continue on. In some languages, so that's the way that C chose to handle it, is using labels. In BASIC, which was another early programming language and a bit of a rival to C that eventually died out because C is so much better. In BASIC, this was done using line numbers. The line numbers in BASIC had to be added manually to your source code. You were responsible for numbering your own lines in BASIC. Imagine that one for a moment. Appreciate your modern programming languages, you young people. So, generally speaking, the effect of all of these goto statements was to make programs impossible to read. And this originates the pejorative term spaghetti code. So what spaghetti code means is that your code looks like a big ball of spaghetti. You can't tell where one thread ends and another thread begins. It's just one big jumbled mass, right? And that's what happens if you rely exclusively on goto statements. It's like you're going up here, you're going down there, you're going in the middle. It's like impossible. Although the computer can jump around the code very effectively, your visual cortex and your reading ability can't. not to nearly the same degree. So it becomes impossible for a human being to read the code effectively, and that means that, like, Bug City, man, just Bug City. If statements and while loops are, technically speaking, syntactic sugar for specific goto structures. Technically, modern control flow is less flexible, but more easier to use and reuse. So that's the thing, right? If statements and while loops are specific goto structures, in the same way that a for loop is a specific type of while structure. While these are the most commonly used forms of goto statements, the goto mechanism itself is actually more flexible, right? So C has goto statements, but their use is discouraged in the strongest possible terms. So to use goto statements, I know I'm almost out of time, which you should never, ever, ever, ever do the following. Create labels within your program. A label is any valid identifier followed by a colon, and create goto statements referencing the labels. For example, here you go. We have a label right here. Inside here, we have a goto statement, and it just goes to the label. This is what the implementation of a do while loop looks like using if statements and gotos. Right? This is basically counting up to 10 using gotos. Speak not its name, yet lest ye go mad. And the reason you don't use gotos is that you get attacked by raptors if you do. I could restructure the program's flow, or I could use one little goto instead. Screw good practice. How bad could it be? Compile. And then he gets attacked by a raptor. I guarantee you, if you use goto statements, you will get attacked by extinct animals. Or dinosaurs like myself. Anyway, so are there any questions about any of that? If not, well, if there are no questions, give me a thumbs up. If there are questions, please ask your questions. Otherwise, you will be allocated your designated 20 minutes of Pizza Pocket microwaving time in preparation for your lab that you have for 2 hours after this. Yes. Yeah, don't use goto. Unless you're programming in assembly, in which case you have no other choice. Do not use gotos unless you have no other choice. Like gotos, I think you can use gotos to jump inside of functions that you haven't actually called and stuff like that. Like, they are very, very dangerous. Like, if you want to break things quickly, use gotos. Yeah. I'm not teaching it to you so that you can use it. I'm teaching it to you so that you can appreciate the gifts that you've been given. It's like studying how in the medieval... it's like studying medieval dentistry. Its primary purpose is for you to appreciate modern dentistry, because people have a problem appreciating modern dentistry a lot of the time. Yeah. Okay. Anyway, I'm gonna log off here. Take her easy, folks. Have fun with the lab today. The topic is you're going to be reconstructing a Unix file system using your basic Unix commands that you learned in the last one. I shall have no mercy for people who submit their labs late. Anyway. Have fun. Don't do anything I wouldn't do. Don't get attacked by raptors.